Hello, and welcome to our presentation. I'm Adrian Best, and along with my team, I'll be telling you about SOS 2, supporting our seniors, supporting our students. These are difficult and unprecedented times where individuals are facing a wide variety of stresses due to the effects of the COVID-19 pandemic. Our story follows two individuals who face challenges in the current situation. Meet Sam Senior. Sam is a Canadian senior living alone in downtown Toronto and needs help buying groceries. He doesn't have anyone to ask for help on a regular basis. Luckily, we have our next fellow. And this is Johnny Kidd. He's a university student in between 3rd and 4th year whose co-op offer was recently rescinded. He's decided to volunteer to help out his community and to qualify for the Canadian Emergency Service Grant. This is where SOS 2 comes in, bringing students and seniors together. The purpose of this app is to match student volunteers with seniors who need assistance. Sam needs someone who can get groceries for him, and Johnny needs to make ends meet and is happy to volunteer. This is what the flowchart would look like from the senior's perspective. It involves the SOS 2 platform, as well as the Firestore database and Directions API. If a senior has trouble with technology, they can always call the SOS 2 hotline with speech-to-text and text analysis features. We'll go over a front-end demo, then the back-end demo of each of the Google Cloud Platform tools. Sam has a smartphone and is looking to find a volunteer using the SOS 2 app. He clicks Sign Up, then clicks his account type. I'm a senior. He inputs his personal information and proceeds to select what he needs help with. In this case, it's just buying groceries. He then clicks Find Me a Volunteer. This is where the back-end magic happens. Based on geographical region and eventually weekly availability, SOS 2 is querying the Firestore database for a match. Sam is matched with Johnny. The app will eventually have a sophisticated platform for service requests and what the interaction would actually look like from user to user. Now for the back-end demos, starting with speech-to-text.
We decided to implement the speech-to-text API with the natural language API due to the fact that we wanted to address accessibility concerns for the elderly who may have physical limitations that deter them from being able to type on a keyboard. Based on the information being said, the speech-to-text will be broken down into components that will be used in the text analysis. The text analysis analyzes the entities in the components and then stores the relevant information in a text file that will be used by the Google Firestore. Here's a demonstration. My name is Sam Senior. I am 72 years old. I live on Victoria Street, address number 325. My postal code is N5G2W4. I need groceries. Quit. This information is now stored in the firedb.txt file and is now sent off to the database.
I'll be demonstrating the Firestore database API. You'll notice two categories here, students and seniors. At the moment, we only have one senior. In the bottom here is the text file I need to parse and upload. Here's the code that parses the text file and then uploads it to the database. Let's give it a try. Alright, the document was successfully uploaded to the database. And there it is, S Senior, with the information we asked for and then a little bit more because the Directions API, which we'll go into next.
Both the senior requesters and the students' locations were asked during the initial prompt and inputted into the previously mentioned Firestore database. These locations are then used to obtain the latitude-longitude coordinates from the API's JSON output, which will then be used to create a rangefinder algorithm. This rangefinder algorithm calculates the distance range between the requester and each available student. We assume that the student would have a preferred distance range to travel. Therefore, we set a distance range value and compare it with the calculated distance range to decide whether the student is adequately near the requester's location. In addition to the rangefinder algorithm, a travel duration or arrival time were obtained from the JSON outputs and given to both the requester as well as the student if the request was accepted.
That's our presentation. Thank you for watching, and we hope you enjoyed it. Remember, SOS 2, supporting our seniors, supporting our students.